Section 10.6 is about exponential and logarithmic equations and some further applications of them. So let's talk about some properties for solving exponential and logarithmic equations. For all real numbers b greater than 0, where b doesn't equal 1, and for any real numbers x and y, the following hold true. If I have b to the x equals b to the y, then then x has to be equal to y, right? That kind of makes sense. Like if I have 2 to the x equals 2 to the fourth, x has to be the fourth. If I have log base b of x is the same as log base b of y, then I also have x equals y. And we're going to use this property to solve some examples. So if I have log base 5 of 2x plus 11 equals log base 5 of 3, that means that 2x plus 11 equals 3. Now I have a single variable equation, and I can solve by subtracting 11 from both sides. I get that 2x is negative 8, so x is negative 4. If I have 3 log base 2 x equals negative log base 2 of 27, the first thing I want to do is rewrite this as a single logarithm. So I'm going to put this constant back as an exponent. So I get log base 2 of x equals, this is a negative 1, right? Log base 2, x cubed equals log base 2 of 27 to the negative first. So that means x cubed equals 27 to the negative 1. So x cubed is 1 over 27. If I take the cube root of both sides, I get that x equals 1/3. We can also solve exponential equations by writing them in logarithmic form. So I can't think of anything nice, right? 3 to the x is 14. So what I'm going to do is I'm going to rewrite this as a log. I can write this as the natural log of 3 I can write this as log. Okay, it's going to be log base 3, not the natural log. Log base 3 to the 14 is x. I can solve this using change of base theorem. I can rewrite this as log of 14 for log of 3 equals x, and then I could go ahead and find an exact value. The value I get is 2.4 equals x. Let's try this again. Now I have 7 to the negative x plus 4 equals 17. I'm going to rewrite this as, I'm going to solve this one by taking the log of both sides. So I have log of 7 to the negative x plus 4 equals log of 17. And remember, I can take the log of both sides because I want to get this exponent, my variable, to no longer be an exponent. I could have solved this problem on the left the same way. I could have taken the natural log of both sides. So I'd have natural log of 3 to the x is 14. Then I would move this to the front. So I get x natural log of 3 is the natural log of 14 because you have to do it to both sides. Divide both sides by the natural log of 3. So I get x equals the natural log of 14 over the natural log of 3, which would give us that same answer. But because this one, but I'm going to solve this one the other way by taking the log of both sides. So I have negative x plus 4 times the log of 7 equals the log of 17. So I have negative x log 7 plus 4 log 7 equals the log of 17. I'm going to subtract 4 log 7 from both sides. Again, we're trying to isolate that x. So I get negative x is times log of 7 is log of 17 minus 4 log of 7. And I divide all of that by negative log of 7 because I want a positive x. So I get x equals log of 17 minus 4 log of 7 over negative log of 7, and that's actually going to give us 2.544. Next, we're going to practice solving these by writing them in their exponential form. Lots of practice today. So if I have log base 2 of x plus 5 cubed, I'm going to rewrite this as I've got what we're looking at. So I've got x plus 5 cubed equals 2 to the 4th. So now what I'm going to do is I'm going to have x plus 5 cubed equals 2 to the 4th, which is 16. Now it may be very tempting to cube this right here, but that's not what we want to do. I'm going to go ahead and take the cube root of both sides. Yes, I can do that. So I get x plus 5 equals the cube root of 16, which we know simplifies to 2 cube root of 2. I can subtract 5 from both sides. So I get x is negative 5 plus 2 cube root of 2. Let's work through another example. So if I have log base 3 of 4x plus 1 equals 4, and I rewrite that as an exponent, again, this is asking what power do I raise 3 to get my argument, which is 4. So I have 3 to the 4th is 4x plus 1. Well, 3 to the 4th is 81. 81 is equal to 4x plus 1. I subtract 1. I get 80 equals 4x. So that means that if I divide both sides by 4, x equals 20.